All right, let's talk about some more advanced features. This is probably not stuff a lot of CS1 students are going to do, but I have the content available, and there's usually one or two students per term that get maybe more. They get excited about animation, and so I want to have, and especially switching screens around. So I want to have content available for all the different possible things students might want to do. So and I'm calling this Zelda 3 because it's my third attempt to re-implement chunks of The Legend of Zelda, the 1986 NES smash hit that I lost a bunch of my middle school years to. So let's, the usual thing here. You get Zelda 3, you unzip it, you jump in, you pop this thing open. I've already opened it, so I'm not going to open it again. And here we are. Now, watch this. Isn't that great? I got the music in. I'll show you. Let me move you down here. I'll show you how that works. Um, I got some other cool features. Let me turn this down and run it again, maybe. Let me just show you what happens. You can run around. You can go to another screen. You can hit F, is it? Or E? Yeah, E brings in enemies. They just randomly appear and they chase you. Look at this. Now, as you notice, the backgrounds, you can just run over stuff. There's not really anything going on there. Um, but it's the whole original map. You can just run through the water because these are just images. There's no like useful content to them. Um, One other thing, how do I bring up the dial? Oh yeah, there's the dialogue window. I have a dialogue window. I have enemies. If the enemies hit you, the dialogue window pops up. And I can hit space, and the character vaguely is animated. Okay. Hopefully you could hear any of that with the music going. We'll find out. Okay, so let's go through how all of that works. So, first things first. Uh, well, what is first things first? Let's start with the music. So if we look at my world, we've got our instance variables. We've got our constructor, which configures a bunch of things. Um, but the main thing that does the music is this started method. So the constructor actually gets called like now, even though I haven't hit the run button, the constructor's been called to sort of like construct the world. So if you start playing music in the constructor, it starts playing just right away, which is kind of annoying. I want it to play when I hit this button, but not otherwise. So what I've done is I've put it in this method called started. This method is what gets called when you push that green button. It just gets called like when you start with the green button or like when you pause and resume, it'll get called again. Something like that. And then I'm just loading the sound. I put it in the sounds folder instead of the images folder, and I'm just telling it to play in a loop. So it's like 3 minutes long. So it plays through and then it loops back to the beginning and plays it again, which is basically what the game does. I just downloaded it from online. I mean, the Legend of Zelda music is pretty famous. It's all over the place. Symphonies play it. It's not hard to find a zillion different versions of it. This is as close to the original sound from the original NES as I could find. So that's how the sound works. Now, how about the map? So the map, believe it or not, is this, huge. I can't, well, let me look at the code. It'll tell me the dimensions on the map. So the map is 8 rows and 16 columns. So it's 8 high and 16 wide. That's how many screens there are in the Legend of Zelda world. Now that's just the overworld. There's dungeon screens as well. I didn't do anything with dungeons. The player starts out at row 7, column 7, so basically in the middle at the bottom. Now, I played the game for years, and it never really occurred to me that I started out start the game at the bottom. Like you can't go any lower than where you start out. You're at the very bottom row. I never figured that out when I played it. Bad sense of direction. I've got this 2D array of Greenfoot images. Those are all of the different screens, right? So every sort of background screen I just loaded as an image. Um, and then this is just telling us, okay, how many rows and columns are there up here? And current row and current column is where is Link, the main character, currently. So in the constructor here, we're making it 256 times 4 and 176 times 4. Why did I pick those? 256 by 176 is what the images are that I found. And I'm multiplying them by 4 because I want to make them bigger. So then when I put the background image on it, it's scaling it. Because if I just make it 256 by 176, it's too small and you can't really see anything. So I wanted it to be proportionally bigger. Um, I'm initializing my array of screens. That's great. And now if you look here, I've got this for each loop. I'm going through all my rows and all my columns. So through the 8 rows I have, through the 16 columns I have. And if you notice, I'm creating a file name, chunk underscore row underscore column dot png. And then I've got an images backgrounds, this file name. Look what I've done. So in images, in backgrounds, you can see I've got chunk 00. That's actually the top left. And then and they're not exactly sorting correctly because 14 sorts before 4 because 1 comes before 4. So it's not exactly in the right order. I should have done 00 to, you know, but whatever, I didn't. Who cares? But 00, that is the top left. So you can see, that's top left of the map. And then I guess 715 would be the bottom of it. So that's like, yeah, 715 is the bottom right. Link starts out at 77, his little home. So you can see that's what is that? That's this one. That's the starting screen. So these are all just sort of labeled and numbered to find out where they go. And I'm pretty sure I found them this way online. I didn't credit where I got them from because these are just ripped straight from the original NES ROM. So technically, I'm massively violating, copyright and whatever. But listen, I'm gonna call this what do they call it? Uh, it's not really fair use. I'm not really commenting on it. It's fan fiction. There we go. That's what I was going for. I'm creating Zelda fan fiction right now. That's how I would describe it. But anyway, that's the naming convention, and so that fills up all of this Greenfoot image, this screens with rows and columns. Then you can index into it to get to what you're looking for. I'm setting the background to current row, current column. That's basically 7 7. So that's my background screen. And then I'm adding the player to, get width over to, get height over to, basically in the middle, which is pretty true to how Zelda works. Spawn enemies. This method just spawns enemies. Change screen. Here we go. Delta row, delta column. So as the player's walking around, you might need to change screens. How do you change screens? When you hit the edge of the screen, you need to change screens. So what I've done is our current row. So delta row and delta column is either 0 if we're not changing the row, and then +1 or -1. -1 for row would be we're moving up because 00 row is top left and then it sort of goes down and over. So +1 would be I'm moving down, -1 I'm moving up for rows. For columns, +1 means I'm moving right, and -1 means I'm moving left. That's my right and my left. I don't know if you're seeing it the other way, but right versus left. And so if current row plus the delta row, and again, the delta row might be negative, is sort of less than 0, return, because we can't go off the edges. So there are boundaries, right? We can't go off the very bottom or the very top or too far right of the map because, I could set it to sort of wrap around, but I didn't. So there sort of are edges to the map. So if you try to change screen and you're at the edge of the map, it just, nope, that's not going to happen. It'll just sort of block it. Otherwise, we change our row and column by the deltas. And then if there's any enemies, the Octoroks, we're just going to basically just remove them all. So if you leave the screen, it removes all the enemies. That way, when you change screens, if there were enemies right behind you, they don't just appear in the same spot of the new screen. That wouldn't really make sense. They get stuck on the previous screen. So just removing enemies if we go off the screen. And then we're setting the background to wherever we currently are. Now, that's not too surprising as for what's happening. The challenge here is how do we figure out delta row and delta column? That's one of the things we'll have to figure out, but I'm just sort of showing you this is how we're checking the boundaries so we don't go off the edges. This changes the row and column, this clears the enemies, and then this changes our background image. So this is just a very helpful method. I don't want to talk about dialogue yet. Here we go. So act, if I hit space, that toggles the dialogue, true or false, whatever. I'll come back to that. Um, and then E spawns the enemies. Okay. And these are act methods like just for the world. So I've decided that the dialogue is a property of the world rather than like the actor or the player or something like that. Then we got methods for getting current row and getting the player. Okay, great. Um, let's look at player next because player is probably the most interesting thing. Um, I'll talk about all of this in a bit. This is well, this is not complicated. This is just how fast the player moves. This is for animation. I'll return to that in a second. I want to talk about how the screens change first. So I'm going to ignore all of this about frames and animation counters, animation speed. Just ignore that for now. So the player, we're going to sort of load the image for the player, and then this is getting all the different images. This is all just animation related. Just ignore that for now. I'll come back to it. The act method for the player, we get the world, and then we just do the regular checking. Well, if we're moving left because the key's down, and I'm doing either the left or I'm also doing WASD for movement because WASD makes a lot more sense. And then you're driving with your left hand, which for right-handed people is kind of the standard for video games. Um, so we sort of do this is the check to see if we went off the screen, right? So we're like, oh, okay, if get X, so our current X coordinate minus speed, which in this case is 6, or moving 6 pixels per frame. If that's less than or equal to 0, meaning we sort of went off this edge, then we're going to set location to 0. So sort of keep 0 in the X direction, and then get Y is our whatever our uh, hold on, minus speed less than 0 minus. Oh, this is just making sure that if we were about to go over the left edge of the screen, that we actually don't go over the left edge of the screen. So if this would be less than 0, this is a bounds check. So this is like it's what's called clamping. So we get to the edge of the screen and we would go slightly off. We don't want to go slightly off. We're just going to set that to 0, right? Otherwise, we just go ahead and make the move. This only happens if X isn't going to get negative. This is for animation. We'll come back to that. This is for moving right. This is checking if we don't go off the width to the right. So, the width -1, because if it's 600 wide, that goes from 0 to 599. So we're making sure we're not greater than width -1, whatever. So this just makes sure we don't go off to the right, make sure we don't go off up, make sure we don't go off down. So that's just checking for all of that. We also have this method, check for screen change. So this is going to check to see if we did get to a 0 in any of those directions. That's going to decide it's time to do a screen change. So let's look at this method, check for screen change. So again, all of this is just clamping. It's making sure that we don't go negative in the sort of X or Y direction or sort of too positive to get off the edge. We basically just like don't physically move our sprite off the edge of the screen. We clamp it to exactly the edge of the screen. Okay, so now this check for screen change, what is this doing? It's getting the world, it's getting our current row and column, and it's getting the number of rows and columns. Now it's going to check, okay, make sure our X isn't less than 0, and the current column is greater than 0. So if that's the case, if X is less than or equal to 0, it's really just equal 0 because we've clamped it, but whatever, we're checking less than or equal. So if basically we got to 0 and the current column is greater than 0, meaning we're not at column 0. Column 0 is the edge of the screen. You can't go left anymore, right? So if we're column 1, we could go left. We can switch the screen. So if that's the case, I'm going to do world.change screen 0 -1. Now, again, this change screen, what does this do? Let's look at it. Delta row, delta column. What are we saying here? Well, we're not changing the row. We're not moving up or down, but we are changing the column by -1. Why? Well, because we got to the X coordinate 0 and our column indicated that we could move left. So if that happens, we change the screen, right? We just go ahead full on, change the screen. to whatever the new background image is, and set location world.getWidth -2. What does this mean? World.getWidth, um, we're keeping the y coordinate the same. So whatever our height is when we get to the left edge of the screen, get width -2 means we're going to just like reappear on the right edge of the screen. This sort of seems weird if the background image isn't changing, but it makes sense if the background image is changing. I get to the left edge of the screen. I'm able to keep walking. I get to 0. Okay, now I change my column by -1. I leave the row the same. So I get a new background image. I load that in and I warp myself to the right edge of the screen, right? So I went off the left edge of one screen and I appeared at the right edge of the next screen. And then once you understand that, all these other ones, these other 4 cases are just the other possibilities. I went off the right edge, I went off the top, I went off the bottom. And it's just checking all of the various conditions. And you can sort of walk through this code. This is the easiest one to understand because we're just checking if it's like less than 0 and column is greater than 0. These are more complicated because we have to check like, okay, if X is world width -1. So if we're like at the right edge and then current column is less than the number of columns -1, meaning there is still one more column to the right. These conditions are a little bit more complicated, but it just means the same thing. It means we got to the right edge of the screen, but we're not at the right edge of the world. So there is something else to the right that we could load. We can still do like sort of a delta to the right, and then we warp ourselves. And instead of setting this to 0, I set it to 1. So we're like a little bit, not exactly on the left edge. We're like a little bit over from the left edge. Yeah, so that's checking for screen changes. I think that's pretty cool. We can do it in any direction. If you're doing a side scroller game, that might be something you want to do as well. When you get the right edge of the screen, you sort of move over or something like that. If you're doing a lot of the side scrollers, like there's a moving window of what you're seeing. There's different ways you could do that in Greenfoot. You probably wouldn't literally have like a big world with a camera that's following around. Probably what you would do is just have the obstacles move from right to left, and then you would stay in the middle and kind of move along them. That's probably what you would do, but there's different ways to approach it. But this is really cool. This screen changing. This is how we're managing it. We're just using the coordinates, and we just have an array, a 2D array of all the images, and we just like load the appropriate image, and we just provided methods to do all of that. So that's one, I think, really cool feature that this attempted Zelda has. Now the images they're just background images. It doesn't care if you're touching a wall or you're touching a tree or something like that. You just walk over everything because they're just paint. They're just images. They're not real. I never got that far to figure out how to make the walls, you bump into the walls and you can't move over them. I'll figure that out later. Let's talk animation. So for animation, we have left images, right images, up images, and down images, and these are arrays. So if we look at the constructor for the player, we've got images player, that's the path, that's in the images folder, which just the same place we've put all the other images. And I instead of throwing all the images in together, I tried to sort them out into folders. That's why there's folder for chunks and a folder for player and a folder for enemies and whatever. Left images, it's an array of just 2, and there's left 1 and left 2. And then there's right 1 and right 2 and up 1 and up 2 and down 1 and down 2. And then initially we set our image to, down images 1, which means Link starts out facing down. Let me show you a little bit about these images. So if we go here into player, you can see there's down 1, down 2. This one is just, the legs are here, and this one, the legs are a little bit different. So if you flip back and forth between those images really quickly while he's moving down, it looks like he's walking. The legs move a little bit. Same here, left, 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 left. If you flip between those images, it looks like he's walking. Same with right, same with up. And in fact, left and right, I think, are just mirror images of each other. So really, you just need to do up, down, and left. And then for right, you could just mirror the image. You just flip it. I mean, a lot of people will actually do that, where they'll do that in code. I just went ahead and flipped it in the in the actual images because I just thought it would be easier and more consistent just to have everything clean this way and not have to use code to go flipping the images. But sometimes you'll see people do that. It doesn't really matter. So that's what's happening. We're going to flip back and forth between those images. Now, how does that work? Well, let's look at the act method. If we're moving left or right or up or down, this is just doing the clamping to make sure we don't go off the edge of the screen. This is the animate movement method with left images. And why are we using left images? Well, because we're traveling left, because we're either pushing the left arrow or pushing A. Well, let's look at animate movement and see what that's all about. So animate movement takes an array of Greenfoot images, and what it's going to do, it's going to increase the animation counter. And if the animation counter mod animation speed is 0, it's going to increase the frame. So the frame is frame plus 1, mod images length. So basically, it's going to flick back and forth between those images. So it's going to tell us like what frame we're at. So the frame can keep increasing. But we're always going to mod it by images length, which is just 2, and that's going to flip back and forth between them. Now, we're not going to do this every time step. That would be like, that would be crazy. We're going to do that only every, when animation counter, mod animation speed is 0. And the animation speed, if you look up here, is set to 10. So that means every 10 acts, there's going to be 9 acts where we keep the left image, and then left 1, then we flip to left 2 for the next few ticks, right? If we didn't do that, then it would just flip back and forth between them. Well, that act is getting called like 30 frames a second. Well, if you're flipping back and forth 30 frames a second, it's just going to look like an insane blur. You're not going to be able to see anything. So in fact, let me show you what that would look like. If we cut this down to 1 and recompile it, and I apologize, this one is very slow. Let's see what this looks like. See what I'm saying? That doesn't look very good. So we can go in here and be like, okay, well, and if we set this to like 50, and run it, now it's like, boom. Like it takes forever to switch the image because we're getting 50 frames before we switch. So how did we figure out that the value is 10? I don't know. I tried some values and 10 is what worked the best. I guess I do have an issue. Am I going to get over 2 billion of any of these and have these roll over? I don't know. If I do, I'll just it's never happened yet. I'm not going to stress about it. So that's what's going on with animate movement. We tick up, and this, an animate movement, remember, it's getting called with a set of the images in the act method, which means it's getting called every frame, essentially 30 frames a second, say, or 30 time ticks a second, whatever you want to call it. So we're increasing that animation counter, and if that animation counter mod the speed is 0, that means, okay, it's been 10 frames, or 10 10 frames out of our 30 frames a second, or whatever it is. So it's time to switch the image. And then which image isn't? Well, we take our frame, whatever frame we were at, we add 1 to it, and then we mod it by the length, and that will flip to the other frame. And then we set our current image to whatever that frame is. Then the animation counter goes, none of this happens for a while. We're moving, and then, it's time to switch it again. So the frame switches back to the other one. So this basically just toggles back and forth from 0 to 1, 0 to 1, 0 to 1. No big deal. There's other ways to do this. I mean, I did mod by images length in case I had a version that had like 3 images or 4 images for animation, which a lot of sprite-based animation doesn't just have 2 images, it'll have several. So by having this be images length, that's really good because, it could be any number. And this formula will figure that out. And that's really all there is, honestly, to animation, for sprite-based animation to sort of build that into this. I mean, you got the frame counter, the animation counter, and the animation speed. You can tweak this, and you can tweak the speed, and you can sort of just find values that seem to work pretty well. So that's all we're doing for the animation. And then where did I get these images? I don't think these are rips of the original link. I think these are fan-made copies, and I don't remember where I got them, but it was from itch.io. I will try to track that down and credit this. I'm doing a bad job of crediting people, but it's on my to-do list. I will try to get that done. Okay, so screen changes, animation. We've got a few other cool features in here. Dialogue. This was wild. So for dialogue, uh, I made a Greenfoot image with the width and a height. I set a font to Courier font with 30 point Courier font. The dialogue has a width and a height and a text. Um, Set the width and the height, create the image of the appropriate width and the height. I set the color, so that's why the dialogue has a black background. I filled the rectangle from the width and the height, starting at 0, 0, filled it width and height with white. No, I didn't. I set the I set the color to black and then filled the rectangle with black, starting from 0, 0 width and height. So basically, I set color black and then from 0, 0 to width and height, I did a filled rectangle. So that's why that entire dialog box is black. Then I set the color to white. Now I draw a rectangle from 1, 1 to width -1. That gives a tiny little white border around the edges. Um, that was kind of cool. And then I'm setting the font to this font that I defined. And then I'm going to set the text and then I'm going to draw the image. And so that's what like gets us the sort of, dialogue window. And then anything that wants to mess with the dialogue can just go take a dialogue object and set its text to something different. When you call set text, what do? Well, we clear the image, we sort of redo all of this, we set the color back to white, and then we draw the string inside there for the text at 10 in the X direction and height over 2 in the Y direction. Probably if we wanted this to be more versatile, we would have to like figure out how big the words are and do word wrapping and all this other stuff. I just don't care about any of that. There's usually libraries that do that stuff these days, and I just don't want to muck around with font sizes and whatever else. It's a solved problem, and I'm gonna let somebody else deal with it. But this is just a really basic dialogue box that was like good enough for what we were doing. So that gets us the dialogue window. And you can see in my world the uh, act button here. If the spacebar gets hit, um, if spacebar is down and the dialogue is visible and the spacebar and this, I'll show you what this does in a second. We remove the dialogue message, but if the dialogue's not visible, we set the dialogue message and then it shows up. Um, this here with having like, hey, is key down space and spacebar not down, and then not is key down space and then spacebar down false. This is because I was getting issues where it felt the thing seemed to think I was holding the space down, and I wasn't. I was just tapping it once. And I think there's ways to do this using not is key down, but get key. Um, but I haven't fixed it to do that yet. But let me give you the general idea. So this spacebar down is initially false, and let me show you what this does. So if you hit the spacebar, the dialogue's either visible or not. And if this variable spacebar down is not set to true, so it's false, what are we going to do? Well, remove the dialogue message if it was visible and set spacebar down to true because we're holding the spacebar down or we've hit the spacebar. If dialogue's not visible, we make it visible, but we still make spacebar down true. Now, if we're holding spacebar down too long, what's going to happen? Well, if the spacebar is not down, meaning we've released it, then we set this to false. If ever spacebar down is true, since this is an and, this will come back as false, which means we'll never do this. That way we don't accidentally hold the spacebar down and have the dialogue like toggle on and off, on and off, on and off. Let me show you what this looks like if we get rid of these, um, just so that you can kind of get a sense. So we run it, and then, yeah, see it flicker? So that isn't what I want, and so that is why I put these in there. Now, is that necessary? I don't think so. I think that I could do this a different way, doing if think it would be space dot equals uh, Greenfoot dot get key. Uh, and dialogue visible. I'm gonna try this out and see if I can simplify this a little bit. And then this one would be basically the same way. I would say else if Greenfoot. No, I would say else if space dot equals Greenfoot dot get key and not dialogue visible. I don't know. Let's see if this works. Oh, didn't like this. That's because I'm missing that. Blah blah blah. Okay, let's see if this works. Definitely doesn't. Doesn't work at all. Why? Who knows? Um, I don't know why. I don't know why. Maybe world is different than actor. Maybe I have no idea. Um, Probably I did this already and then it didn't work. And then I was like, whatever, I just need to get through class. And then I just wait, no, hold on. That's not what I wanted. What I wanted was this, and to get rid of this stuff that doesn't work. I think there's a way to simplify this and not do this in this way where we're like using these booleans to track whether we're accidentally holding something down too long. Um, I'm sure we can fix that, but I just haven't yet. Anyway, that's the dialog box, which is activated with the space bar. Let me show you, I guess the last interesting feature are the enemies, these Octoroks. So these, their act method, we get the world that they're in, we get the player's X and Y, and we turn towards that X and Y and move one. So basically what these things do is they appear in the world. If the players, they find the player and they turn towards the player and then they move towards the player. Um, that's essentially what they do. And if they're touching the player, they tell the world to set the dialogue to say, "Hey, I hit you." Um, that's basically what they do. And we spawn them in the world if we just hit the E key. I don't know why I picked E. I just did. And then I have the same true false so that we don't accidentally hold the E down. I'm sure there's a better way to do this. It's driving me crazy with these booleans, but I'll fix it later. We call spawn enemies, and if you look at spawn enemies, what does this do? Where are you, spawn enemies? Hello, there we go. We get the player's X and Y. We don't want to spawn enemies right on top of the player, and then we get the world width and height, and then I set this jitter to 30. And so for each of these three, we put it in world height, get random number minus jitter something something. I don't even know if we use this player X and player Y. I guess you could spawn them right on top of the player. Basically, this jitter, it's just like spawning three enemies in um, the Y and the X coordinate. We're just using random numbers and adding some different things to it and whatever else. And then we're creating the Octorok and then adding the object to those coordinates. So that's basically what's happening. And then what they do is they find the player, they turn towards the player, and they move towards the player. So they're using like really stupid AI to chase the player. They're not smart enough to like work together and head off the player and this, that, and the other thing. They just, seek and destroy. Let me look at my slides and make sure enemies, primitive animation, changing backgrounds, music, and dialogue windows. Nope, that's everything. Yeah, so that's Zelda 3. That's again probably more sophisticated than what CS1 students are going to want to do, but still um cool stuff, especially the animation. I know a lot of students want to do animation, and so it gives the possibility. Should also mention that animation you can do if you go to itch.io and start searching for sprite sheets, you can find really cool artists that have put their work up that you can use for free if you just credit them or for non-commercial purposes or something like that. And you can do a lot with other people's art assets just to kind of get a feel for things. Um, yeah, anyway, so that's what I have for Zelda. Thanks for watching.